You begin your journey not by stepping forward, but by falling inward, softly, slowly, into the space between things. Between breath and thought, between time and stillness, you drift downward, like a feather spiraling through silence. You, past the skin of your own body, slipping beneath cells, beneath atoms, beneath the very idea of form, until you arrive at something quieter than quiet, the quantum realm. Here, nothing is quite as it seems. Shapes blur, rules bend. Particles flicker, into and out of being like candlelight in wind. There is no solid ground to stand on, only probability, possibility, presence, and yet it does not feel chaotic. It feels intentional, like a whisper passed through centuries of silence, still waiting for someone to listen. You are not alone here. All around you, particles shimmer like stars underwater. They spin, they hum, they dance in ways no eye could follow. Each one contains a secret, a kind of quiet instruction on how the universe builds itself, not from bricks or blueprints, but from relationships, from rhythm, from resonance. They do not shout, they do not clash. They simply move together, apart, and sometimes as one, because sometimes two particles born together or brought together become something more. Entangled, that is the word. It sounds like vines twisting gently around each other in the dark. But here, it means something stranger, something deeper. These particles, once entangled, are not just companions. They are reflections, mirrors across space. What happens to one, the other somehow knows, instantly. No matter the distance between them, it's not communication, not in the way your voice travels through air. It's not a message. It's a mirror. Turn one, and the other turns. Flip one, and the other flips. They respond without hesitation, without signal, as if they were still part of the same thing. Because perhaps in some way they are. You try to picture it. Two particles on opposite ends of a vast, silent ocean. One deep within your hand. One buried in the soil of a distant moon. And yet, move one, just nudge it slightly, and the other stirs. As if the ocean between them had never existed. This is not a trick of science fiction. It is science, quietly verified through delicate, thoughtful experiments. Again and again, physicists send twin particles down separate paths, down fiber. Optics, across cities, even through open air. And again, those twins behave as one. As if they share not just a past, but a present. As if space itself cannot pull them apart. You close your eyes and imagine being one of those particles. You remember the moment you were born, wrapped in the energy of your pair, spinning in a shared rhythm. Then suddenly you are split, carried off in different directions by unseen hands. Yet somehow you are never truly alone. Somewhere your partner still spins, and your spin matters to them. Even now, it's a strange kind of intimacy, isn't it? Connection that needs no presence, no words, no visible thread. Just the echo of shared beginnings. You begin to wonder, what else in the universe carries this kind of bond? What else is quietly linked behind the scenes, invisible to the eye, but deeply, deeply real? Quantum entanglement stretches the very way you think about space, about time, about separateness. It suggests that the world is stitched together more delicately than we ever imagined, not just through cause and effect, but through something subtler. Through entanglement, the universe may not be a scattering of distant things, but a tapestry, where pulling one thread gently stirs another, far away. And yet, entanglement does not let us send messages faster than light. It does not let us cheat distance. What it does offer is something softer, a clue, a whisper, a quiet affirmation that the universe holds deeper truths than our eyes alone can see. You breathe. The thought settles into your bones, slow, warm, full of weightless mystery. You begin to wonder how this is even possible. How could something like this exist in a world where every action should have a cause, a signal, a step-by-step explanation? How could one particle know what's happening to another without ever touching it? This is where the story becomes even stranger, even more beautiful. Because this mystery once unsettled even the great minds, even Einstein, who found it too spooky to believe. He could not accept that nature allowed such instantaneous connection. And so he searched for another answer, something hidden, something logical beneath the surface. But the particles did not agree. They kept whispering their shared truths. And other minds, curious, patient, began to listen. And so your journey does not end here. It turns now toward those voices from the past, toward the man who gave quantum entanglement its nickname, and the paradox he tried to untangle, because the whisper between particles may be quiet, but the questions it leaves behind echo far and wide. You find yourself floating, suspended in the stillness between stars. Space stretches endlessly around you, dark and quiet, and yet you do not feel alone. There is something, a presence, a pull, not of gravity, but of connection. You close your eyes and reach with your mind instead of your hands, and somewhere, impossibly far, something answers. Not with words, not with sound, but with motion. A response. A mirror movement across the void. This is the thread, invisible, weightless, real. Entanglement isn't a bond you can see. It's not like a string or a rope, not something you could tie or cut. It's more like a silent agreement between particles, a vow made in the moment of their creation, that no matter where the universe flings them, they will remain one story told in two places. One coin flipped in two hands. You picture the thread, stretched across space, from your fingertip to the edge of the moon, or from the center of your chest to the surface of a quiet lake on another planet. If one particle turns, the other turns. If one shifts, the other follows instantly. It's as if space doesn't matter, as if the concept of here and there has unraveled. This idea is not just poetic, it is measurable, repeatedly tested in labs that hum with precision and patience. Scientists fire photons through crystals, separating them and sending them down fiber optic cables that win through cities. When they check their properties, the results match perfectly, impossibly, just as if they'd never been apart. The particles don't seem to communicate. They simply know, and the thread remains, even across kilometers of concrete, mountains, and air. But what is this thread made of? Not atoms, not energy. It's something subtler, something built into the rules of reality itself. When two particles are entangled, their properties are not separate anymore. They're linked in a way that defies our everyday thinking. Their identities are fused, as if they were notes in a shared chord, vibrating in unison, no matter how far apart they are played. In your world, things take time to travel. A phone call bounces through towers. A letter moves through hands and trucks. Light takes 8 minutes to reach you from the sun. But here, in the quantum world, a change in one particle is mirrored in the other, with no travel, no lag, no medium. As if the message was never sent, because the separation never existed. The void between them, it seems, is only a trick of perspective. You begin to sense that perhaps this thread, this entanglement, is not the exception, but the rule, that the universe itself may be woven from these connections, that everything is stitched together by silent agreements, by partnerships between particles, hidden beneath the skin of what you see. You imagine particles being born, twins in a burst of energy, spinning together in harmony, then torn apart by time, flung into separate corners of the cosmos, and yet still linked, still echoing each other's changes, not through force, not through commands, but through something stranger, shared identity. Entanglement doesn't break. It fades only when the particles are disturbed, when heat or noise or interaction unravels the thread. Until then, it remains. Fragile, yes, but precise. So precise, in fact, that entire technologies are beginning to rise from its foundation, like quantum teleportation, which uses entanglement to transmit the exact state of a particle from one place to another. Not the particle itself, but the information, the essence. You breathe in slowly. The idea settles into your chest like mist. Reality is not made of pieces scattered in a box. It is a tapestry, one where pulling a thread on one side ripples the pattern on the other, one where even silence is filled with connection. And if particles can be entangled, could systems? Could memories? Could we? Some scientists wonder, could the particles that make up your body still hold traces of their ancient entanglements with distant stars or with the soil beneath the sea? Could your mind, your thoughts, your dreams be more deeply connected to the universe than you've ever imagined? This is not to say you can read minds or speak across galaxies, but it is to say that the world is less separate than it seems, that everything is more softly braided together. Entanglement doesn't shout. It doesn't need to. It simply is a quiet defiance of distance. And in that defiance, a door opens. Not to science fiction, but to science itself. Real, tested, repeatable science that tells you the universe is not cold. It is connected. You drift there for a while, gently turning in the dark, feeling the thread between things not as a rope, but as a presence, a symmetry, a knowing. And you realize you too are made of particles. You too are stitched into this invisible web. The same forces that bind distant photons may still hum in your atoms like echoes of forgotten conversations. The space between you and the stars may not be as empty as it seems. And now, just as you're beginning to settle into this thought, another voice stirs, not in words, but in resistance. A famous voice, skeptical and sharp. Einstein thought he didn't like this idea. He didn't trust this thread. He searched for cracks in it, tried to untangle what others took as truth. He called it spooky action at a distance, and he meant it as a criticism. But the universe had other plans. And in the next chapter, you will walk alongside Einstein into the paradox he helped create and the strange riddle he couldn't quite solve. You drift now through a quieter space, not physical, but historical. The hum of particles fades, replaced by the rustle of paper, the ticking of a pocket watch, the slow shuffle of leather shoes on a tiled floor. You are in a study lined with books, where equations are written not in chalk, but in thought. And the mind that lives here is formidable. Albert Einstein, a name that echoes through time like a bell, sits by the window, his brow furrowed, eyes distant. He has already reshaped the universe once, revealing that space and time are not rigid, but fluid, bent by mass and motion. But here, in the quiet corners of quantum mechanics, he is uneasy. Something doesn't sit right. It is the entanglement, the silent, invisible bond between particles. To Einstein, this isn't a charming mystery. It's a problem, a puzzle with missing pieces. Because in his world, nothing can travel faster than light. No signal, no influence. Distance takes time. Space has rules. If one particle changes and another responds instantly, no matter the gap between them, then something is deeply wrong. Either information is moving faster than light, or the particles are not truly separate at all. So Einstein reaches for logic. He doesn't deny the experimental results, not entirely, but he refuses to believe the explanation. He suspects something is hidden, a deeper layer beneath what quantum mechanics has revealed. He imagines hidden variables, secret instructions each particle carries from the start. Like twins given matching scripts before they part. He writes a paper with two colleagues, Boris Podolsky and Nathan Rosen. Together, they present a thought experiment, the EPR paradox, arguing that quantum theory, while successful, must be incomplete. If entanglement exists as described, then either information travels faster than light, or reality, as we know it, is somehow non-local. Einstein does not call it beautiful. He calls it spooky action at a distance. And he means it with a frown. You pause here, beside his desk. Outside the window, trees sway in the wind, but inside, the air is thick with resistance. Not anger, not arrogance. Just doubt. Careful, rigorous doubt. Because for Einstein, the universe should make sense. It should follow rules. Even the strange ones in his own theories of relativity still hold a deep logic. But quantum entanglement, it whispers of a world where effects appear without causes, where distance vanishes without explanation. That kind of world, he cannot accept. And yet, others can. You drift forward in time now. The books grow newer, the equipment more precise. A gentle, thoughtful man named John Bell enters the scene. He reads the EPR paper not with scorn, but with curiosity. Instead of dismissing Einstein's concerns, he leans into them. He asks, "Can we test this?" Bell devises a way to measure whether the universe behaves according to hidden variables, or whether it truly allows for instant, non-local entanglement. His theorem is subtle, elegant, powerful. It says, if particles are carrying secret instructions, their outcomes will follow a certain pattern. If not, if quantum mechanics is right, a pattern will break. And so, years later, the experiments begin. Photons are entangled and fired apart. Scientists measure their properties at great distances, carefully avoiding any possibility of hidden communication. Again and again, the results defy the local realism Einstein held dear. The particles don't behave as if they're carrying secret scripts. They act like dancers reacting to each other in real time, even when separated by kilometers. The thread is not illusion. The thread is real. You breathe gently, letting this settle. The very fabric of space seems to quiver with meaning. Einstein's ghost still lingers, not defeated, but silent. Perhaps he underestimated how strange reality could be. Or perhaps he glimpsed a deeper mystery that still waits in the dark. Because, even now, entanglement raises more questions than it answers. How does the connection work? Is space itself an illusion? Is information somehow outside time? And yet, the phenomenon remains. Predictable, measurable, quietly astonishing. It is not magic. It is not fantasy. It is how the universe behaves, whether we like it or not. So you sit for a moment in the presence of these minds, Einstein, Bell, and all those who followed. You understand their doubts, their wonder, their need for truth. And as you prepare to move forward, you realize something important. This strange thread that Einstein once feared, it is not dangerous. It is not spooky. It is intimate. It is gentle. It is the soft murmur of a universe more connected than we dared believe. And in that connection, something new is born. Something even Einstein might have smiled at if he'd only lived to see. You are resting now in the quiet glow of all you've learned. The particles, the paradoxes, the gentle defiance of distance. But tonight, we drift from equations into emotion, because what happens between entangled particles feels familiar, strangely human, strangely tender. Imagine two hearts that once beat side by side, lovers, friends, siblings, separated by oceans or time. Still, when one stirs in sorrow, the other feels it. When one lights up with joy, the other smiles, not knowing why. They are no longer together, but they are not apart. Quantum entanglement is not love. It has no desire, no feeling. But the way entangled particles behave, instantly mirroring each other, responding without signal, bound beyond space, invites the mind to draw parallels. The language of physics begins to sound like poetry. You picture it now, two particles born together in a single burst of energy, a kind of cosmic cradle. In that moment, something links them, a shared spin, a matched state, a symmetry too, deep for words, and when they drift apart, they do not forget. Even when light years away, one still echoes the other. It's not communication. It's identity. When you measure one entangled particle, you instantly learn something about the other. Not because it sent a message, but because the two are not fully separate. They're part of a shared description of reality. Pull one thread, and the other QUIVERS. It's like a melody that only makes sense when played together, even if the notes are miles apart. This is how physicists describe it. The entangled particles exist in a joint quantum state. Neither has a complete story alone. Only together does the story resolve. If one spins up, the other must spin down. If one shifts, the other compensates. They are not two things. They are one thing, expressed in two places. And in that thought, something deep and quiet stirs in you. Because isn't that how some relationships feel? A friend finishes your sentence before you speak. A mother knows her child is in pain, even from afar. A person you love moves across the world, but you still feel them, not as a memory, but as a presence. Of course, this is not quantum entanglement. It's not measurable or testable in the scientific sense, but it reveals something poetic. That our longing to stay connected, to remain part of each other across distance and time, is mirrored by nature itself at its most fundamental level. You are made of particles, billions and billions of them, and some of those particles were once paired in the cores of stars in the early hush of the cosmos. Who is to say that some small echoes of those entanglements don't remain, not in a mystical way, but in the structure of matter, in the fabric of being? Entanglement reminds you, separation is not the only story. Sometimes being apart is still a kind of being together. And as you let that idea settle into your breathing, slow, steady, warm, you realize that even science, when told softly, can be a kind of lullaby. There is comfort in knowing that the universe values connection, not just as a metaphor, but as a fact of physics. This behavior, strange though it may be, is reliable, reproducible, true. The connection between entangled particles is one of the most tested and confirmed phenomena in quantum theory. We can't always explain why it works or how, but we know that it does. We use it to secure data, to build unbreakable cryptography, to whisper information between distant labs with perfect silence. In the quantum world, trust is built not on distance, but on entanglement. The thread holds. And maybe that is the softest truth of all, that in a universe filled with chaos and uncertainty, there exists this quiet promise that what was once joined can remain so across all distance, across all time. You don't need to solve the equations. You don't need to diagram the wave functions or calculate the spin. You only need to listen to the story. Two particles, one beginning, one thread, forever joined. And now, as you rest in that story, a question begins to shimmer on the horizon. If particles can exist in shared states, what does that mean for the very fabric of reality? If distance can be undone, if time can be folded through entanglement, then perhaps the universe is not made of objects at all, but of relationships. In the next chapter, you'll explore how your attention, your simple act of observation, can shape the state of particles. That the universe does not merely exist, it responds. You are floating now, deeper still, not through space, but into a question, A question so delicate, so strange, that it changes the very nature of what you see. What does it mean to observe something? In the quiet world of quantum mechanics, this simple act, looking, measuring, paying attention, is not passive. It is powerful. It is participatory. You are not a distant spectator in the quantum realm. You are a dancer in the rhythm, a note in the melody, a breath that ripples the pattern. Imagine a curtain, heavy and soft, drawn across a stage. Behind it, a performer waits, shifting between roles, prince or pauper, villain or hero. Only when you open the curtain does the performer choose, not because they were hiding the truth, but because the truth hadn't yet settled. It was waiting. For you. This is what quantum physicists call the superposition, a state in which particles hold multiple possibilities at once. A photon may spin left and right, up and down, be here and there, all at the same time, until you measure it, until you look, and the moment you do, the many possibilities collapse into one. Not because the others were illusions, but because your observation defined the reality. You didn't just watch the performance. You helped write the ending dot. It is not that you control the outcome. You do not choose the direction a particle spins. But your presence, your measurement, causes the particle to reveal one of its many possible truths dot in this world. The act of looking becomes a quiet force, not violent, not loud, but decisive. It's as if the universe is waiting to be asked a question, and will not answer until it is. You may have heard of Schrodinger's cat. A thought experiment, not a real one. A cat placed in a sealed box with a quantum trigger is both alive and dead until the box is opened. This is not a cruel idea. It is a metaphor, a way to explain the unsettling truth that particles can exist in all states, until measured dot, and just like the cat, the quantum world waits in limbo. It holds its breath. It hums with possibilities, until you arrive, and the world exhale its answer. This is called the collapse of the wave function, a poetic name for a scientific process. The wave function describes all the ways a particle could exist. Measurement collapses that soft cloud into a single dot, a single result. And you begin to wonder, what counts as a measurement? A machine? A mind? A moment of attention? Physicists still debate this. Some say any interaction counts, any time one system touches another. Others suggest consciousness may play a role, that awareness itself could be part of the equation. We don't yet know. But what we do know is this: your presence changes things. Not because you are separate from the world, but because you are of it. You are not an observer standing outside reality. You are stitched into it. This realization is not just scientific. It is profoundly personal. It reminds you that you matter in the deepest, most literal way. That your gaze is not nothing. That your being here shapes the world in small, real ways. Just like a droplet reshapes the stillness of a pond, your awareness ripples through the quantum field. You take a breath, slowly, softly. The air around you doesn't change, but something inside you settles. The particle doesn't spin until you look. His story doesn't end until you turn the page. And perhaps you too are in a kind of superposition, a cloud of potential, waiting gently to unfold. Your thoughts, your choices, your dreams, each one nudging the world in a new direction. And so you ask, if observation collapses the wave, does love collapse loneliness? Does kindness collapse cruelty? Does attention collapse chaos into meaning? No scientist can answer these questions, not with numbers, not with data, but in the quiet space between particles, you sense a truth that doesn't need proof. That being present is enough. That showing up changes things. That seeing, truly seeing, is its own kind of creation. The particles respond. The world responds. You are not a machine taking notes. You are a participant shaping the dance. And just as this thought begins to drift into sleep, something else stirs beneath it, a whisper from the heart of the quantum world. If particles wait to be measured, if possibilities wait to become real, then what does that mean for space itself? Is distance real? Is here truly separate from there? In the next chapter, you will explore a world where location is illusion, where distance dissolves, and reality becomes something far more intimate than you ever imagined. You are floating again, weightless in the hush of the universe. But now, you notice something strange. You cannot tell where you are. There's no edge, no border, no fixed point. Everything feels soft, suspended, unanchored. This is not a mistake. It is the shape of truth in the quantum world, a place where the map folds in on itself and location becomes a matter of probability, not position. You have always thought in terms of here and there. One hand and the other, one star and the next. But at the level of particles, smaller than anything your eyes can see, these boundaries blur. A quantum particle does not sit quietly in one place, like a marble in a bowl. It spreads out, like a mist. It lives in a cloud of maybes, hovering between locations. This is called a probability distribution, a way of saying the particle might be here, or it might be there, or somewhere in between. It isn't lost. It isn't uncertain in a careless way. It simply is many possibilities at once, waiting for reality to make a choice. You can imagine it like a sleeping bird resting in a tree, not in one branch, but in all of them, softly shifting, feather by feather, until your gaze lands on it. Only then does it choose a perch dot. This behavior doesn't fit into the tidy boxes your everyday mind prefers. But in the quantum world, it is perfectly normal dot, and it leads to something even stranger, something gently breathtaking. Entangled. Particles, remember, behave as one system, no matter the space between them. But how can that be? How can two things separated by mountains, cities, even stars, remain part of a shared state? Because in quantum physics, distance isn't always real. Not in the way you're used to. In the realm of entanglement, location loses meaning. A concept of separate places begins to fade. A measurement made here affects a particle over there, not because something traveled between them, but because the two are never truly apart. The universe doesn't always obey the grid we place on it. It doesn't always color within the lines. Sometimes the universe draws connections where we see emptiness, and maybe, in some deeper way, it is less like a map and more like a song. Each particle a note, each measurement a harmony, the space between them filled not with silence, but with resonance. This is called non-locality, the idea that events or properties are not confined to a single point in space. The particles are not sending signals to each other across the room. They are simply part of the same unfolding, even when separated by vast distances. You don't need to understand the math. You only need to feel the shape of the idea. The universe might not be a collection of distant stars and scattered atoms, but one great whole, softly vibrating in tune with itself. You, too, are not a thing placed in a location. You are a process, a rhythm, a pattern of activity flowing through space and time. The cells in your body are made from particles that once drifted in the cores of stars, the iron in your blood, the calcium in your bones, the carbon in your breath. You are the product of ancient explosions and quiet fusions. You are not from here or there. You are from everywhere. And maybe, just maybe, this is the truest lesson of the quantum world, that the divisions we draw between self and other, between now and then, between one place and the next, are not always real. They are useful illusions, painted over a deeper unity. A unity in which here is not so different from there. And you are not so different from everything else. The particles remind you, everything touches everything, even in silence, even in stillness. And now, as your breath slows and your mind begins to drift, you feel something beautiful and strange begin to rise. A question, soft and weightless as starlight. If particles are connected beyond space, if you are stitched into the same fabric as the stars, then what holds this invisible tapestry together? What law, what logic, what gentle rule binds it all? In the next chapter, you will meet the man who asked this question with more precision than anyone before, and whose quiet insight changed our understanding of entanglement forever. You drift now into a quieter kind of curiosity, not the awe that comes from starlight or the thrill of paradox, but something more deliberate, more precise. A question sharpened into form. A mind seated in silence, thinking slowly and clearly. That mind belongs to John Bell. He was not loud, not famous in his time. But Bell asked a question that rang through the corridors of physics with quiet, unstoppable force. Can we prove whether entanglement is real? Until Bell, most physicists had accepted entanglement as a strange quirk, a useful trick of math that gave the right results. Einstein didn't believe it. He called it incomplete. Others avoided the mystery altogether. But Bell, calm, thoughtful, exact, decided not to look away. He did something simple and revolutionary. He built a test, a way to tell the difference between two worlds. One where particles carry secret instructions, hidden variables that tell them how to behave, even when they're apart. And another, stranger world, where the particles are truly entangled, and no hidden script explains. Their dance. His method became known as Bell's theorem. It told physicists, if reality is truly local and real meaning, if particles are separate and have definite properties before we measure them, then certain patterns must hold true in experiments. But if quantum mechanics is right, if entanglement is not just an illusion, then those patterns will break. This is the quiet bell rang. A thought experiment at first, but soon tested by careful hands. And once it rang, it could not be unrung. You sit with this for a moment. The air feels still. This is no longer about belief or beauty. It is about evidence, proof, what the universe itself says when we ask with enough care. So scientists began to test Bell's ideas. They used pairs of photons, particles of light, and sent them in opposite directions. At each end, they measured properties like polarization at angles chosen randomly. Over time, they gathered patterns. Thousands upon thousands of measurements, logged with care and patience. And what they found was clear. The results did not follow the rules of hidden variables. They did follow the predictions of quantum mechanics. The particles behaved as if they were truly linked, not by a message, not by a plan, but by entanglement. As if distance didn't matter. As if the two photons were still part of one single, indivisible system, split in space, but not in essence. Again and again, with better technology and stricter methods, the tests were repeated. Loopholes were closed. Precision improved. And the results remained the same. Bell's inequalities were violated. Quantum mechanics was right. Entanglement was real. You take a slow breath. The implications echo like a chime in a dark cathedral. Because Bell didn't just confirm a theory. He redefined the boundary between what we call real and what we call connected. He showed that the universe cannot be both local and deterministic in the way Einstein had hoped. Something had to give. And what gave, what fell away, was the comforting illusion of separateness. Particles don't just behave as if they are linked. They are linked, fundamentally, mathematically, physically. And this means the universe is more unified than we ever thought. Not because of mysticism, because of data. Bell never shouted his findings. He wasn't a showman, but his work reshaped quantum science more than perhaps any other mind since Einstein himself. And yet, in his lifetime, he remained modest, teaching, thinking, gently guiding the conversation forward. You picture him now, a quiet man in a quiet office, looking out a rainy window, sketching lines of logic that would ripple through the world like distant thunder. And you feel grateful for the care he took, for the clarity he gave, for the courage it took to ask, what if the world is stranger than we're comfortable admitting? And what if that's okay? His question and its answer is you something rare, a truth born of silence, a mystery resolved not by wonder, but by work. And yet the wonder remains. Because now you know this, entanglement is not a metaphor. It is not an illusion. It is part of the blueprint of reality. You can measure it, chart it, use it to build quantum computers, quantum encryption, quantum networks. But you can also sit with it, like you are now, and simply feel its weight. You are not as separate as you once believed. Not from the world, not from others, not even from the stars that shine above your roof as you drift to sleep. And as this chapter comes to a close, a thought lingers like the last toll of a distant bell. If the universe is connected beneath space, if every part knows something about every other, then what else might be possible? What else might we build, not just from atoms, but from entanglement? In the next chapter, you'll leave theory behind for a moment and step into invention, into the world of quantum computers, where entangled particles do not just reflect each other, but think together. You drift now from thought experiments and proofs into the gentle hum of machines, but not machines like those you know. No gears, no clinking metal, no grinding cogs. These machines speak in a language softer than sound, quieter than a whisper. Quantum computers. They are born from the strange truth you have come to know, that particles can be entangled, connected, across space, their states woven into one another. Instead of bits, zeros and ones, these machines use qubits, particles that exist in superposition, able to be both 0 and 1 at once. This dual nature allows quantum computers to explore many possibilities simultaneously, like a dancer tracing countless paths at once before settling on a step. It is a dance of probabilities, a weaving of futures. Imagine you are trying to find your way through a vast labyrinth. A classical computer would walk down each corridor, one by one, checking each path. Slow, deliberate, step after step. A quantum computer, by contrast, moves through all the corridors at once, every path illuminated by the superposition of its qubits, narrowing down the correct exit with breathtaking speed. Entanglement is the key to this magic. It is the thread that ties qubits together, allowing them to share information instantly, to coordinate their dance without spoken words. Without entanglement, quantum computers lose their power. With it, they can solve problems that classical machines cannot touch, but quantum computers are fragile. Their qubits are delicate, easily disturbed by heat, noise, or stray particles. They require ultra-cold temperatures and extreme care, a quiet laboratory, far from the hum of everyday life. You imagine a chamber glowing softly with blue light, wires like veins pulsing with possibility. Scientists in careful suits monitor the dance, coaxing qubits to stay entangled, to hold their superpositions just long enough to perform their calculations. Though the machines seem small, their potential is enormous. They may revolutionize cryptography, chemistry, material science, and artificial intelligence. They may unlock secrets hidden deep in the folds of mathematics, or simulate molecules too complex for any other computer to grasp. And yet, despite all this promise, quantum computers remain mysterious, even to those who build them. Their power is a reminder that reality itself is not what it seems, that the quiet rules of the quantum world govern the very fabric of information. You feel a sense of awe, tempered by calm, because this is not just technology. It is an invitation to imagine a future where information flows not through wires, but through entangled particles woven seamlessly across space, where the boundaries between here and there soften, where distance is no barrier, and where computation is a dance of delicate connections. You breathe in this vision. It is quiet. It is tentative. It is filled with possibility. And as you settle deeper, you wonder if machines can harness entanglement to think, if particles can hold shared states to solve problems, and what might the human mind, made of particles and waves, be capable of? Is it possible that the dance of entanglement reaches beyond machines and particles? That the connections you feel to others, to the world, to yourself, are part of this same invisible web? The quantum computer whispers possibilities, and in its soft glow, you feel your own thoughts expand, like the superposition of a qubit, ready to collapse into something new. As sleep begins to pull you gently toward its embrace, a final question lingers in the quiet. What new worlds might be born from the threads we cannot see? What new stories might unfold when connection is the true foundation? In the next chapter, you will explore the frontier where entanglement meets reality, where these invisible threads begin to weave the fabric of the cosmos itself. You drift now beyond machines and particles, beyond the laboratory's glow, into the vast tapestry of the cosmos itself. Imagine the night sky not as distant stars scattered in empty space, but as shimmering points in a vast web threads of connection, weaving through everything. Scientists have begun to wonder, what if entanglement is not just a curiosity of tiny particles, but a fundamental thread woven into the very fabric of the universe? Space and time, the dimensions you move through every day, might themselves emerge from this invisible network of quantum connections. Not solid, fixed, or separate, but flexible, entangled, and alive. Picture the universe as a grand loom, where the strands of entanglement bind together particles, fields, and forces into a seamless whole. Each thread contributes to the shape and flow of space, crafting the contours of reality itself. This idea challenges everything you thought you knew about distance and separation. It suggests that space is not a container holding things apart, but a bridge built from countless invisible links. The cosmos, at its deepest level, might be a quantum web, endlessly interlaced and vibrating with potential. Physicists speak of this as quantum gravity and holographic principles, complex words for the notion that the universe's geometry and information are one and the same. Space, time, matter all arising from the patterns of entanglement. You imagine how this feels, not as isolated islands, but as an ocean of connections, waves overlapping, rhythms intertwining. In this vision, you are not a single point floating, alone in space, but a knot in the cosmic net, part of a larger dance. The light from distant stars reaches you not merely by crossing empty space, but by flowing along these quantum threads, carrying stories from across time and distance. And if the universe is a woven fabric of entanglement, then you begin to see yourself in a new light, not just a collection of cells and atoms, but a living part of this grand, connected whole. Your breath slows. Your heartbeat feels steady and deep, aligned with the rhythm of the cosmos. The invisible threads remind you, separation is an illusion. Distance is a veil, and connection is the true nature of all that exists. As you prepare to drift further into sleep, you hold this thought close, soft, profound, and full of wonder. If entanglement weaves the universe itself, then every moment, every interaction, every breath is part of the cosmic dance. And you, too, are a thread essential, connected, shining in the vast, Silent web. In the next chapter, you will journey inward to explore how the science of entanglement touches the very essence of what it means to be you. Now you turn your gaze inward toward the quiet universe within yourself. The same strange, wondrous principles that govern the cosmos also whisper inside you, in the cells, the atoms, the particles that form your very being. You are not a solid, separate thing. You are a shimmering field of energy, a dance of particles, entangled with one another and with the universe beyond. The atoms in your body were once part of stars, clouds, oceans, and soil. Their particles may still carry traces of ancient entanglements, silent threads reaching across space and time, weaving you into the story of everything. Imagine yourselves not as isolated units, but as communities bound together by subtle quantum rhythms. These rhythms influence how molecules fold, how neurons fire, how memories form. Scientists are just beginning to explore this mysterious frontier, the role of quantum processes in biology, consciousness, and life itself. Though much remains unknown, one idea grows clear. Connection is fundamental, not just outside you, but inside. This means your thoughts, emotions, and awareness may be part of a vast, interconnected web, linking you to the world in ways both seen and unseen. Your mind is not a lonely island. It is a symphony, a harmony woven from countless strands of interaction within your body and beyond. As you breathe slowly, feel the gentle flow of this connection, the pulse of life, the ebb and tide of energy, the invisible bonds threading you to the stars, to the earth, to every living thing. You are not just in the universe. The universe is in you. This is not metaphor. It is science whispering its deepest secret. And in this quiet understanding, there is comfort. You are never truly alone. Your being is a beautiful entanglement, a shared story, a connection without. And as sleep embraces you, let this thought settle like a soft lullaby. You are both particle and wave. You are both here and everywhere. You are part of a cosmic dance, forever entwined. And as the night deepens, a final gentle question drifts to the edges of your mind. If connection is the fabric of reality, then how might your life, your choices, your love, ripple through the threads of the universe? In the next chapter, you will rest in the silence of that question, the beginning of a journey as vast and mysterious as the cosmos itself.